Good morning. Today we are continuing working with those angles, and we are going to be working with triangles also. So in order to do that, we need to know what a triangle is. Well, we're doing CO54. I can classify a triangle by its sides and its angles. So we're going to be using angles and the sides to know what type of triangle it is. So our definition of a triangle is it's a polygon with three sides and three angles. Angles always sum to how many degrees? Anybody know? Matthew? 180 degrees. So when you have a triangle, you will know that always, if you add up the three angles, it will equal 180 degrees. So to find some of those angles, we need to use what we already know, what we've already learned. We need to know that a right angle is 90 degrees. We need to remember those supplementary angles, because that is going to come into play also. So there are several different types of triangles, and we can classify them by their sides. There are certain words we use for sides of angles, and then there are certain words or sides of triangles, and there are certain terms for the angles. So there are two different ways to classify triangles. And we need to know those different names. We need to know if they're sides that go by these names or if they're angles that we use those names. So I'm going to move up so we can see better. This first section, you need to know that these are how we classify it by its sides. We use the word scalene, isosceles, and equilateral. Those are all side. We look at their sides to know which type of triangle it is. So our first one is a scalene. A scalene triangle has no equal sides. An example of this might look like that. We might say this is a 4, this is a 6, and this is a 7. None of their side lengths are equal. No congruent sides. Remember, congruent means equal. Then we have our isosceles triangle. Isosceles triangle has two congruent sides. And we know that they're congruent. Either we get the side measurements or we have those marks. When there are two sides with the same mark, we know it's an isosceles because those two sides are congruent. They are equal. If we have our numbers on it, we can see that they have the same measurement. Our last triangle with classifying by the sides is the equilateral triangle, and that means all three sides are congruent. So we would see that, there we go, by all three sides have the same line, all three sides would have the same measurement. So if all three are the same, an equilateral, lateral means side. So if you know some Latin, we should be picking up Latin with some of our math terms with the counting, like bicycle is bi is 2, triangle, tri is 3. Okay, so if it's lateral in the word, you know that it's talking about sides. So if it's equilateral, all the sides are equal. So whenever you see lateral, you need to know that it's talking about sides. This is important because we're going to see a very similar triangle name under our angles. If we look over here, we see an equiangular triangle. Angular refers to the angles. So when it comes time to take the test and it says, what is an equiangular triangle? If you say all three sides are the same, is that correct? No, because angular is talking about the angles. You would have to say three congruent angles. So you need to know the difference between angular and lateral. Knowing what we know about triangles, and if all three angles are congruent, they're all the same, what measurement does an equiangular triangle have to have for each angle? Which would be what? It can't just be 70 degrees, 70 degrees, 70 degrees, because if I add all three of those up, it's not 180. Oh. Do you think you know, Luciana? Yeah, what is the angle measurement for always for an equiangular triangle? Yeah, so what angle would that be? James? 60. Yeah, it has to be 60 degrees for each angle. No other angle, if you added all of them up, would you get 180 degrees. So if it's an equiangular triangle, it will always have 60 degrees for its angles. Just like a right angle is always 90 degrees, an equiangular triangle is always 60 degrees. So now let's talk about these other types of triangles. We have an acute triangle. What do we know about acute angles? Jillian? Yeah, an acute angle is less than 90 degrees. So an acute triangle has three acute angles. So it might look something like that. It could be 60 degrees, 40 degrees, 80 degrees. As long as each of its angles is less than 90 degrees, it is an acute triangle because all of the angles are acute. What do you think about a right triangle, Riziki? So that's what a right angle is. What do you think a right triangle is? Aiden H?
Is it like two angles? No. I didn't like draw the box. It's like
How much, JT?
it has one angle that's 90 degrees.
It's going to have one right angle. Why could we not have two right angles?
A triangle. Because that would be a square.
Yeah, because I can't have two right angles and only three lines. It wouldn't be a triangle. So it has to have just one right angle. Remember, those right angles equal 90 degrees. And you can see that right angle because there's that little box in it. So a right triangle has one right angle. Now our last one is an obtuse triangle. What is an obtuse angle? Aiden H?
It's an angle bigger than 90 degrees.
An angle that's bigger than 90 degrees. So what do you think an obtuse triangle is?
It's a triangle.
Jillian?
A triangle bigger than 90 degrees? Angle.
It has how many angles would be obtuse?
90.
How many angles of the triangle would be obtuse? Do you think all three of them could be obtuse? So if we look at an obtuse angle, could I put another one in that's obtuse? No, because it wouldn't end up being a triangle. So for an obtuse triangle, one obtuse angle. Just like with our right triangle, you can only get one in there. Otherwise, it wouldn't be a triangle. Wow, I'm not good at drawing my lines right now. So an obtuse triangle has one obtuse angle. So it is bigger than bigger than 90 degrees. The other two have to be acute, otherwise it wouldn't be a triangle. Triangle can only equal 180 degrees. So if we're over that 90 degrees for one of our angles, we can't have another one that's over 90 degrees because then it would be bigger than 180 and it wouldn't be a triangle. So key things to remember. How many degrees does a triangle always equal? Everybody. 180 degrees. What? Our lateral means what? Lateral means, just give me the one word. Sides. Lateral means sides. So if it's an equal lateral triangle, it means the sides are equal. What does angular mean? Angle. So if it's an equal angular triangle, it's about the angles. So you have to remember, if we're talking about the angles of it, equal, they're all three the same. Obtuse, one is bigger than 180. Right, one is 90 degrees. Acute, they're all acute angles. Those are triangle names when we classify by the angle. Classifying by sides would be the scalene, the isosceles, and the equilateral. You have to keep those straight. On your help sheet, you can write all those definitions out. I highly recommend that you do that for when it comes time to the test. Write out which triangle names are our classified by sides and which triangle names are classifying by the angles. It's super easy to confuse them. So make sure that you know which are our side triangles and which are our angle triangles. Yeah, this is Mr. Schultz's math program. He takes the book and he uses all the information from the book to make our objective pages, and then he takes the test off of the objective pages. But it's all the information from the book.
Doesn't he run the program?
He does run the math program.
So he makes tests for every single way.
On PO55, it says PO55.
Yes, because that is a silly Mr. Schultz thing. Okay, so this is a two-page assignment. Let's look at the bottom of the first page. We need to classify each triangle by its angles and sides. So you need to know, is it scalene, is it isosceles, is it equilateral? And then you have to look at the angles and classify it by the angles. So if we look at this first one, it gives us the side measurements and the angle measurements. So first we're going to put what its angle name would be. What is its angle name? So looking at our angles, what would we call this triangle? A and B? We have a 70 degree, a 70 degree, and a 40 degree. So are there all three acute? Is there one right angle? Is there one obtuse angle? Or are all three congruent? We're going by angles first. So we're writing down the angle name first. It's acute. All of our angles are acute. Am I done answering my
Oh, I
question?
know the other one too.
We need to do the side. So what would my side be, Aiden? Isosceles.
Yes.
Because two are congruent. We have two sides that are the same, so it's an isosceles. So the full name of this triangle is an acute isosceles triangle. So let's look at our next triangle. What is the angle name for it, Ethan?
It's a right angle.
There is a right angle in it. We know this by right there. That's why they didn't give us any other angles, because we knew it was a right angle triangle right away. Now we need to finish it off with our sides. So what side name does it have, Ethan?
The SCA.
Scalene. So it has the word scale in it, scalene. I say scalene, yeah, that one. And if you write it on your help sheet, doesn't matter if you can pronounce it correctly, spell it correctly. Okay, we have a help sheet. We need to be able to spell these words correctly. I'm gonna let Riziki do the last one.
Okay, so its angle is obtuse.
Yes, there is an obtuse angle in there.
And then its sides would be scale.
Yep, it would be scaling because all the sides are
Like that.
different.
It's okay.
All right, so looking at how they drew out their triangles with the angles, with the measurements, with the side lengths, we're gonna look at the top of our next page. We're going to draw our triangles. Do we have to be precise?
No.
When I was drawing my example, when I was drawing my examples, did I get out my protractor to draw? No, because by this point we can kind of eyeball it. We know if it's obtuse, it's going to be bigger than the 90. We know 90 goes straight up and straight across, and we know acute is going to be smaller. So we can kind of know, and if one side is a little bit bigger than the other side, we would say that's 7 and that one's 6. So you can kind of eyeball it as long as the measurements that you're putting in follow with the name of our triangle. So if we look at our first one, it says acute scalene. What kind of angles do I all need to have?
One angle is below 90 degrees. One angle.
Look at your paper, she said.
Yeah.
One angle is 90 degrees. Yeah, one angle that's
That's not what acute
one
says.
angle that's 2
What does acute triangle say?
90 degrees.
No.
Three.
3 acute angles. So you have to have all 3 angles are below 90 degrees. So do you have that written down?
Yeah.
Okay. So if it says an acute scalene, first word is the angle, second word is your side length. So 3 acute, and then it's scalene, so all the sides are unequal. So you're gonna draw a triangle with different side lengths, and they're all acute angles. And then you're gonna put in measurements that go with that.
90 degrees.
You're gonna put in degrees, and you're gonna put in side lengths. Because you're gonna show that they are not equal sides, and you're gonna show that all of the degrees are under 90 degrees. So that's how you're showing you know what it means to be an acute scalene. Because you might say, that's 4, that's 6, and that's 8. Maybe this is 35 degrees, this is 45 degrees. So what does this last measurement have to be? Can I use 35 and 45?
No.
Why not?
Because you have different angles.
Yeah, you can.
What would this third measurement be?
10.
How many degrees is
No,
a
it's 100.
triangle?
Oh. 90?
Nope.
No, 100.
180. So if I did 35 and 45,
100.
that equals 80 degrees. What would this angle have to be?
100.
100. Can it be 100 degrees?
Yes.
No.
Maybe.
Yes.
Yes. Yes, I guess.
What kind of angle does it have to be?
100.
It's
100 degrees is not an acute angle.
Oh.
So I can't use these measurements because it would make that an obtuse angle.
Just do all 60s.
Why can I not do all 60s?
Because they can't be all the same.
Because it's not an equal angular. So if I did 45, maybe this one I would make 65, then what would this one have to be? Yeah. It would have to be 70 degrees. Are they all acute? Yes. Are they equal? No, because it's not equal angular. So that would work. So I could use 45 degrees, 65 degrees, and 70 degrees because if I add all three of them up, they equal 180 degrees. I couldn't use my first set because it turned one of my acute into an obtuse, and it's not an obtuse triangle. A triangle always has to exactly equal 180 degrees. It's like a law for geometry. Triangles always equal 180 degrees. Acute is always less than 90 degrees. Obtuse is always bigger than 90 degrees. So those are laws. You cannot break the law. Okay? So you're going to do the equal angular and the obtuse isosceles yourself, thinking about what those definitions tell us. What do our measurements, it's not going to be exact measurements because it's going to vary. You might have a side be 10, a measurement of 10, and somebody else would put it as a measurement of 5. So the thing is you have to know if it's scaling, they're all different. If it's acute, they're all acute angles. Does that make sense? So you have to use your brain on this. You can't just draw and put down any numbers you want. They have to follow the laws. They have to follow those laws that we just learned about. Now, down below, let's determine if the given statement is true or false. If it is false, explain why. So let's look at the first one together. An acute triangle has two angles less than 90 degrees.
No.
Nora, why would this be false? Because it needs three angles. It needs three acute angles. So you have to write a reason why. So when it says explain why, it doesn't have to be some in-depth, long explanation, but you could say it's false because three of them have to be acute, not just two. Okay, that first one that I drew out, and I said, oh, acute angle, what's my last measurement? It was an obtuse, doesn't work. So it has to be all three angles are acute. All three angles are less than 90 degrees. Does that make sense? Then at the very bottom is the time for review. You're going to draw out those different angles. If you need to look back at previous objectives, look back at the previous objectives to remember vertical, complementary, straight, acute, what all of those different types of angles are. You can look back at our previous objectives. Any questions on today's assignment? With that, my friends at home, we hope you are well. We hope you have a wonderful day. And we hope to see you soon.